All right, so here we go. Partial fraction decomposition, but now we have a quadratic in the denominator. However, when we look at that quadratic, we should recognize that we can't factor that. So what are we going to do? And that's why we're here today. What we're going to do is we'll keep the linear term there, and we don't really have any choice but to keep that quadratic just as a quadratic in the denominator. Now, we know that we've been thrown an a there and a b there. This is not going to work with a quadratic in the numerator. Just like with a linear term in the denominator, I should say, with a linear term in the denominator, the degree of this is 1. The degree of the numerator is 0. It's a constant term. The degree of the denominator here is 2. So 1 less of that is a first degree in the numerator, which is a linear term. So what we have to do is we have to write a linear term here. Now think about the equation of a line. Linear terms have two values in them, a slope and a y-intercept. So what we need to do here is we need to set this up, and we'll call it bx plus c. Every linear term can be written in the form bx plus c, so that's what we're going to put. So notice, even though there was only 2 parts to our product in the denominator, we're going to end up with 3 variables. Okay, here we just have the constant in the numerator, here is a linear term. Now it's just like before. Let's multiply by the LCD on both sides. Okay, so on the left we have 8x squared plus 12x minus 20. On the right, distributing x plus 3's cancel, we have a times x squared plus x plus 2 plus, now notice this is a bx plus c times, the quadratic terms cancel, x plus 3. So, just like in the past, we need to do some multiplying, and we want to combine our like terms. Multiplying this is simple. I can distribute the a. But now what do I have to do with these two terms to multiply? Well, I need to FOIL them out. I've got a bx squared plus a 3bx plus a cx plus a 3c. So that's what it looks like to FOIL that out. Now we're at that point where we have been combining our like terms. How many x squareds do we have? A, and then b, and that's it. How many x terms do we have? A, 3b, and c. And then for our constant term, 2a plus 3c. All right, so let's write our system. 8 equals a plus b. 12 equals a plus 3b plus c. And negative 20 is our constant term, so it's equal to 2a plus 3c. All right, there's our system. So what we want to figure out here is our best way to solve this. And I'm looking at, well, that's an a and a, but those are b and c. Those are different, so I can't use elimination here with the top and the bottom one. This one has an extra variable there, so I'm not going to use elimination with that one either. So I think substitution is going to be the route. Let's see here. From this one, I know that b equals 8 minus a. If let's see here, on this one, I can solve this for c. C equals, this is actually going to take a couple steps. I have to subtract over the 2a and divide by 3. Negative 20 minus 2a over 3. And because I've solved for b and c on these, I can substitute that into the green equation for b and c, and I'm only going to have a's left. So this is going to become 12 equals a plus 3 times b, so 3 times 8 minus a, plus c, which is negative 20 minus 2a over 3. And that I'll move to the next page because I can solve this for a. All right, solving this for a, let's see here. What do I want to do? Let's distribute that 3. So that's going to be, what, a 24 minus 3a plus negative 20 minus 2a over 3. I really don't like the fraction that I have in here, so I'm going to multiply everything by 3 on both sides. 36 equals 3a plus, what is that, 72 minus 9a. Now here it's going to cancel, minus 20 minus 2a. So I have 36 equals, how many a's do I have here? 3 minus 9 minus 2, that's negative 6 minus 2, that's negative 8a. And then we have a plus 52 from the 72 and the 20. So let's subtract 52 on both sides. Let's make sure I don't goof this up. I think that's 16. It is, that's a negative 16 equals negative 8a, and we have a is 2. All right, so let's go back here. If a is 2, we can find b. Let's just forget doing that. B is 8 minus a. So b is 8 minus 2, b is 6. C is this, negative 20 minus 2a over 3. I could have used the other equation as well, that's all right. I just picked this one, negative 20 minus 2 times 2 over 3. Let's see here, that's negative 24 over 3. C is negative 8. There are my A, B, and C. Now, I do want to give you, and I know I didn't write out the answer to this, but I do want to give you another option here on solving this once you get to this step. This should look familiar to you. Okay, let's just go back here and let's find that. That's right here. That's just what we got immediately after multiplying by the LCD on both sides. Okay, and we can be a little bit creative here to figure out how we're going to maybe solve for a lot faster than we did in the past. So here's what I notice. I've got this b and c over here. It'd be really nice, okay, if I could just cover that up, okay, and just have a's. So here's what I notice. I notice that if x is negative 3, right, that's in there. What happens? That's 0, which means this entire term, bx plus c times x plus 3, is gone because this is 0, and 0 times whatever that is 0. So we can get rid of this whole part. Now, if we put negative 3 in for these x's, we also have to put them in for all these other x's, and we're going to get a pretty simple equation. So let's substitute negative 3 in for everything. I'll just write 0 because that whole thing's gone. All right, so a little bit of work here. We've got negative 3 squared, that's 9 times 8, that's 72 minus 36 minus 20 equals a times 9 minus 3 plus 2. Let's see here. That's 36 minus 20. That's 16 equals a times 8. And a is 2. Okay. So look how quickly we're able to get a there by recognizing if we substitute a -3, it gets rid of this bx plus c part. Now, how do we figure out b and c? Well, we now know a is 2. So this allows us to come back and substitute a 2 in for the a. And if I put a 2 in there, it now gives me, when I distribute, 2x squared plus 2x plus 4. I'm taking that 2, I'm distributing it in. Plus, okay, now what do we have to do with this? We still have to FOIL this out. We have bx squared plus 3bx plus cx plus 3c. Now we can do our combined like terms, and we just have one fewer variable here to worry about. How many x squareds are there? 2 plus b, x squareds. If you go back to this work, now if we did this method before, we wouldn't know this, but we can look back. When you go back to our work on that, notice we had an a plus bx squared, but now we know a is 2, so we have a 2 plus bx squared. That doesn't surprise me. Okay. How many x's? 2 plus 3b plus cx, and our constant term is 4 plus 3c. And from here, now we can set up our system. 8 equals 2 plus b. 12 equals 2 plus 3b plus c. Now, I'm going to hesitate to write that one down because if I look at this one, -20 equals 4 plus 3c. I think we're good here. Hold on here. Time out. What am I thinking? No, we're good. We can solve those, right? There's only 2 variables here left to solve for. We only need 2 equations and we can get them. From this one, we get b is 6. And from this one, subtract 4, and that's -24, divided by 3, we get b is -8. So we have a is 2, b is 6, c is -8. 2, 6, -8, and we've got it. Let's just take that minute now to write out our answer. 8x squared plus 12x minus 20 over, let's see here, what was our denominator?
Attention all parents.
Over x plus 3, x squared plus x plus 2. I think that's what it was. Yep. And what does that equal? A 2 over x plus 3 plus. Now remember, what went above the quadratic? Remember, it was bx plus c. But now we know b is 6 and c is -8. So there's our partial fraction decomposition when we have a quadratic term in the denominator that can't be factored. Remember, if you've got a quadratic down here, you have to have a linear up there. bx plus c. Now, we'll make one more video here looking at this one, what happens if we have a repeated quadratic in the denominator, and we'll go from there. But that'll wrap up this video. Thanks, guys.